Thank you, Helena, for introducing me. So I'm going to take 10 minutes of your time to talk about two major initiatives at AI Sweden that we are working towards. And I think one of them would classify into this AI security that Helena was talking about. And the other one is probably, with a little bit of imagination, classified into the other leg about enhanced security via AI. I'm going to focus on AI security to begin with. And as Helena said, just iterating a bit, we view AI security as a way to prevent AI from doing what it's not supposed to. Could be some action that it should not perform, or as I will talk more about now, to not reveal what it's not supposed to reveal. This is, of course, something that has been highlighted in many instances, for example, by the US Cyber Command and Director at NSA. And last year in March, about exactly a year ago, the US released a strategy, a national strategy, where they actually pinpoint the issues of information leakage and attacks on AI systems. And in that report, interestingly, they outline several techniques that they need to gather resources around, that they need to build knowledge around, and that they need to understand better. You see that table here. Some of these topics are something that has already been mentioned by Brian and by Helena. For example, federated learning. We have synthetic data. Differential privacy might occur from time to time. And I'm going to get back to this table in this presentation just to show you how we actually cover some of these aspects. Not all of them, but many of them. But yeah, as I said, this problem of information leakage of machine learning models, essentially having machine learning models spit out information that they have been exposed to during training, is something that many different countries are thinking about. US is one, as I said. Britain, we have Germany has released a report on concerns about attacks on AI systems. And even in Sweden, we have done some works on this. So for example, IMI, the Authority for Data Privacy in Sweden, it was founded when GDPR came about, have done, so they have something called regulatory pilots. And they essentially engage in innovation projects and try to view whatever you're trying to innovate from a legal perspective. And they did this in their first regulatory sandbox on federated learning and came to the conclusion that due to the fact that we can potentially attack these systems, federated learning, when we share models between each other, can be viewed as a poor way of communicating because you can extract the information, and hence, if it's sensitive data, you might be violating laws. For this reason, we have started to dig deeper, and we are looking into a very abstract way of leaking information. And I just want to guide you through what that might look like in one instance. So here we have a typical attack on an AI system. You might be familiar with this API access of AI systems. Think about ChatGPT. So we have a data set that is very sensitive. We train a model on it. We take the trained model, we expose it to external parties, could be a customer, could be other companies, whatever, via an API. So the user can only interact with the model by providing an input and retrieving an output. Now, if this user that is interacting with the machine learning model has ill intentions, then potentially you could tailor the input queries according to some objective, read out the output predictions for that query, and forge an understanding about the training data that the model has been exposed to. It sounds exotic, but this is very much possible, and it has been demonstrated over the last 5 years. So it's a fairly new research area, but it's something that is really picking up now, and it's becoming quite hot, I would say. So just to give an example, this is an attack that we have implemented on federated learning. As an adversary, you essentially start from a random guess. I believe that this data point is in the training data set. And now by interacting with the model that you have received at the server side, you can refine this guess. And after a bunch of iterations, you end up with something that might actually look reminiscent of something that you can identify. In this case, this is a toy example CFAR. You can do this on more sophisticated data sets as well. But here, the ground truth looks like this, and you can see that you can really tell that it's a red car. And Of course, you can apply this to faces or whatever personal information that might be around. The problem, though, is that these types of attacks typically make very crucial assumptions. They make assumptions on the way that the model is trained. They make assumptions on, for example, the batch size, the epochs, a bunch of parameters. So you can only really perform these attacks under very, very limited scenarios. And the question then is, how realistic are these scenarios where these attacks are potent? And this is what we are investigating. So we created a project that we call LeakPro, stands for Leakage Profiling and Risk Oversight of Machine Learning Models. We gathered a consortium within the AI Sweden partner network, consisting of technical leaders within federated learning like Scale-Out and synthetic data like SynData, and also major players within life science like Sahlgrenska, Region Halland, and AstraZeneca. And we teamed up to define use cases that we would be interested in understanding, would we be at risk of leaking data? And we are trying to build a general platform that will stress test machine learning models. And coming back to this table then, so these are all the technologies that the US outlined, or that this committee outlined that were important. And what we're investigating in LeakPro are essentially these. So we leave a few of these out because the project is very large in scope, but we are touching on a lot of these aspects, which I believe is very interesting. So the goal of LeakPro is essentially to provide an open source platform to stress test machine learning models. We are extremely interested in taking a step away from the academic sandbox where we only have toy examples, very easy or very, very limited scenarios that we can attack under. And we really care about what are realistic assumptions. Can we attack under these realistic assumptions? So the goal is to consider 4 different scenarios. We have black box attacks, where we can only query and receive an output. We have white box attacks, for example, I think Llama 3 that was released a few days ago, where we can actually access the entire model. We look at synthetic data. How much can we say about the original data if we have access to the synthetic? And we look at federated learning. So if we have a server that is trying to attack the training procedure of a given client, how potent is it? And from my point of view, the most interesting part of this project is really not the technical aspects. It's interesting in itself, but the most interesting part is this interface. This interface is an interface between technical risk and legal risk. And this is a bridge that is very, very tricky to traverse. So we have a reference group consisting of EMI, ESAM, and lawyers from AI Sweden. We have Region Halland providing legal expertise. And recently, we even extended the group to include 4 more organizations, where we discuss solely around what do you need from a technical perspective to reason around privacy risks in AI from a legal perspective. How can we make this discussion move forward? So that's very exciting, I think. And the goal, of course, is then to provide this kind of material to lawyers, provide some kind of auditing trail for how you train models, and then in the end, hopefully get some kind of approval that this model, we believe, will not risk any information that is sensitive. And if we are able to do this and provide such approval so we can start using federated learning in practice on sensitive data, it opens up a plethora of new applications that we can actually, where we can improve current state of performance. For example, one such setting is within money laundering. So money laundering is a very, very good use case for federated learning. We have multiple banks that are obliged to monitor the transaction networks to find illicit transactions. Due to bank secrecy, they are not allowed to share any information between each other, but potentially the surveillance systems might get a large boost and improvement if they were allowed to collaborate. So this is a very simplified view of the problem. We essentially have a transaction network at one bank. We have some accounts in the bank that are illicit. And of course, we would like to find them. In this case, it might be very easy, but this transaction network is enormous and it's developing over time. So we have dynamic graphs. And we have created a synthetic data engine to mimic this transaction network. So just to give you a feeling for how tricky it is, I can show you a small network that we created to play around with that looks like this. All the clusters that you see here are different banks. The black edges are transactions. All the red dots are money launderers. We would like to identify them. It's like finding a needle in a haystack. It's extremely tricky. And as I said, today, banks are operating like this. So they have access to the local transaction networks. They perform the surveillance on there, but of course, transactions go between banks. So the question is, how can we actually leverage that? And what we're trying to do in this project, together with Swedbank and Handelsbanken, is to actually investigate, is there powers in numbers? Can we collaborate on this problem to create better systems to combat money laundering? So we are trying to build something like this. This project has been going on for a year, and we are right now starting to actually train federated models between Handelsbanken and Swedbank, AI Sweden in the middle, on the synthetic data that we have cross-validated towards real transaction data to show that we actually will be able to boost the performance of current systems. All right, so if any of these topics sounds interesting to you, I would like to invite you to come by the posters that we have created to discuss this in more detail. The first poster is about information leakage, and then we have 3 more posters, where one of them is about the federated aspect of money laundering, and the two in the middle here are actually posters that are going to be presented by our master students that are working on very similar topic, or working on the same topic, but from a different perspective. One of the master thesis project is looking at how much does unreliable labels impact the performance of money laundering surveillance systems, whereas the other poster is going to focus on, if we flag an account as a money launderer, how can we explain to an investigator why we actually did so? So explainable methods on graph data that is moving with time. And with that said, I'm not going to take more of your time. I would like to ask Chiara to come up and talk a little bit about what is happening within space. Thank you.